Welcome to class, everyone! I am absolutely thrilled you're here for today's explainer, because we're tackling one of the most fascinating, massive, and just literally awe-inspiring forces of nature on our entire planet. So I want you to picture the immense Pacific Ocean. Now, kind of shrink it down in your mind. Imagine it not as a boundless ocean, but actually as a giant, sloshing bathtub stretching right between the Americas and Asia. Today, we're going to look at how a slight change in the winds blowing across this giant bathtub can completely rewrite the weather, the economy, and the ecosystems of the entire globe. Okay, let's dive right into this. Here is our lesson plan on the chalkboard for today. First, the giant Pacific bathtub. Second, El Niño, little boy. Third, La Niña, little girl. Then, shifting the jet stream. And finally, changing ocean ecosystems. All right, section 1, the giant Pacific bathtub. Normal conditions. Let's kick things off with an absolutely crucial vocabulary term for the test, ENSO. That stands for the El Niño Southern Oscillation Cycle. Now, scientists use this big umbrella term to describe these opposing climate patterns in the Pacific Ocean that basically break away from normal conditions. You see, warmer or colder than average ocean temperatures in one specific part of the world can literally influence weather all around the globe. And ENSO is the engine behind the whole shebang. And this step-by-step really brilliantly illustrates how our bathtub operates under, normal conditions. I want you to think of the equator's trade winds like a giant fan set on medium speed, just steadily blowing toward the west. This fan blows the sun-warmed surface water all the way from South America over toward Asia. So you end up with this massive pool of warm water stacked up on the Asian side of the tub. But, water can't just leave an empty hole behind, right? That brings us to upwelling. So the crucial point here is that when all that warm surface water gets pushed westward by our giant fan, cold water is forced to rise up from the deep, dark depths of the ocean to replace it along the coast of the Americas. It's almost like a drain mechanism working in reverse, pulling up icy, deep water. Definitely keep upwelling in your mind, class, because it is the secret key to our ecosystem later on. Now, the bathtub doesn't stay perfectly normal forever. These disruptive ENSO events act up every 2 to 7 years on average, though. To be fair, they don't follow a strict schedule. Generally speaking, El Niño happens more frequently than La Niña. When one of these events actually kicks in, you can expect it to stick around for roughly 9 to 12 months, though sometimes they can linger for years, creating sustained global impacts on everything from wildfires to ecosystems and economies. Moving on to Section 2, El Niño, little boy. Trade winds weaken. Notice the direct contrast here. During an El Niño event, our giant fan, the trade winds, suddenly weakens. Imagine turning that fan down to low, or actually, maybe even turning it off entirely. All that warm water that was pushed up against Asia, gravity takes over, and it sloshes right back east across the bathtub, pulling up against the west coast of the Americas. The name actually holds some really fascinating history. Back in the 1600s, South American fishermen were out on the water and started noticing these periods of unusually warm ocean temperatures. And because this warm water phenomenon typically peaked right around December, they named it El Niño de Navidad, which translates to the little boy of Christmas. Over centuries, the name just kind of stuck. Let's look at Section 3. La Niña, little girl. Trade winds strengthen. So if El Niño is a weak fan, La Niña is when someone turns the giant fan up to maximum power. No way around it. During a La Niña event, the trade winds become even stronger than usual. They push an excessive amount of warm water intensely toward Asia. And remember that upwelling we talked about? Because so much surface water is blown away, an absolutely incredible amount of cold water surges up from the depths along the Americas. La Niña translates to the little girl in Spanish, acting as the perfect counter to the little boy. But meteorologists and scientists sometimes use other nicknames too, like El Viejo, anti-El Niño, or simply a cold event. Whichever name you happen to prefer, the hallmark is that intense rush of cold, deep ocean water right to the surface. Which brings us to a major question for our class today. We've been talking entirely about ocean currents and wind blowing across this Pacific tub. So how on earth does a warm bathtub change the weather thousands of miles away in a place like Canada or the inland United States? Like, what's the connection? That brings us to Section 4, shifting the jet stream, atmospheric shifts. These vast pools of unusually warm or cold ocean water act kind of like thermal steering wheels for the Pacific jet stream, and that's the fast-moving river of air high up in the sky. During El Niño, warmer waters cause the jet stream to move south, leaving the northern U.S. and Canada surprisingly warmer and drier than usual. But during La Niña, the cold waters push that jet stream northward, slamming the Pacific Northwest and Canada with heavy rains and flooding, while leaving the north wetter and colder in the winter. And the impacts down south are just as dramatic for sure. For the U.S. Gulf Coast and Southeast, El Niño brings wetter periods with a severe increase in flooding as the jet stream dips low. Flip the coin to La Niña, and the South suddenly faces warmer, drier drought conditions. But there's a pretty dangerous catch here. La Niña also tends to create conditions in the atmosphere that lead to a significantly more severe Atlantic hurricane season. All right, our final stop, Section 5, Changing Ocean Ecosystems, Marine Life Impacts. Do you remember upwelling, the rising of cold, deep water? Well, that deep water is incredibly nutrient-rich. It's basically the fertilizer of the ocean. During La Niña, upwelling is on overdrive, pumping massive amounts of nutrients to the surface. This creates a blooming buffet for phytoplankton, which feeds the fish, which feeds everything else. But during El Niño, when the warm water sloshes back east, upwelling weakens, or actually stops entirely. The nutrients get cut off, the phytoplankton starve, and the entire food chain collapses like a house of cards. And this drastically redraws the map for marine life. Because the water temperatures fundamentally shift, the fish literally have to pack up and move. During El Niño's unusually warm waters, tropical species that normally stay near the equator, like yellowtail and albacore tuna, suddenly migrate all the way up the Pacific coast into areas that are usually way too freezing for them. Conversely, during La Niña's intense cold water upwelling, you see a massive influx of cold water species, like squid and salmon, thriving right off the California coast. Well, we've covered a lot of ground today, class. We've tracked how a giant fan over a bathtub can steer hurricanes, migrate tuna, and cause droughts across entirely different continents. I want to leave you with this final provocative thought. How beautifully, terrifyingly fragile is our interconnected world? If just a slight change in the speed of an ocean wind can starve a microscopic food chain in the Pacific and simultaneously flood a coastline thousands of miles away. Think about that next time you feel a breeze. Thanks for joining me for this explainer, and keep asking questions.